The pyramids don't need magic to be terrifying. They need planning, stone, ramps, ropes, leverage, and logistics on a national scale. We have quarry marks, worker settlements, tool evidence, and even written records that describe stone being moved to Giza. The real mystery isn't, how did they do it? It's how they coordinated it with Bronze Age technology and human discipline. This episode is not about aliens, curses, or secret energy. It's about what archaeology actually finds: quarries, sledges, boats, ramps, and the workforce system that made huge construction possible. Where evidence is strong, we say it's strong. Where the exact method is debated, like the final ramp design, we say it's debated, and show the best supported options. Most of the Great Pyramid's bulk is local limestone from the Giza Plateau, meaning huge portions didn't travel across Egypt. The finer white limestone casing came from Tura, and heavier granite used for key internal spaces came from Aswan. The engineering trick begins with smart sourcing. Use local stone for mass, transport premium stone for precision. Ancient Egyptians didn't need modern steel to quarry stone. Evidence supports techniques like pounding and splitting, using very hard stone tools, especially for tough granite. It's slow, labor-intensive, but scalable when you have trained crews and time. The secret is not a futuristic tool, it's an industrial workflow powered by people. One of the most practical methods for hauling blocks is sledges dragged over prepared tracks. Experiments and depictions support that wetting sand can reduce friction, making heavy loads more manageable for large crews. The logic is simple: reduce friction, increase control, avoid wheel failure on soft ground. This is engineering, not mystery, just physics applied consistently. The Pyramid Project wasn't only a construction site, it was a supply chain. Water transport is massively efficient compared to hauling everything over land, so canals and harbor zones near Giza matter. When you treat Egypt like a transportation network, river plus canals plus staging yards, the pyramid becomes less impossible and more like a national infrastructure project. A major evidence bomb is the Diary of Merer, a 4,500-year-old logbook discovered at Wadi al-Jarf. It describes crews transporting white limestone blocks from Tura to Giza by boat during Khufu's reign, exactly the kind of routine documentation you'd expect in a real construction system. This doesn't explain every detail of building, but it proves the project ran on organized logistics, not legend. Excavations around Giza revealed evidence of a planned worker settlement and infrastructure supporting laborers. This strongly challenges the Hollywood slave narrative and fits a model of organized, provisioned crews working for the state. In other words, the pyramids are human, but built by a society capable of feeding, housing, and managing a massive workforce. A pyramid is only as good as its foundation. Leveling the base and keeping angles consistent requires surveying methods, repeated checks, and quality control. This is where magic myths often hide. People underestimate how far measurement and planning can go with simple instruments when used obsessively. The miracle is discipline. Most serious explanations involve ramps, but not necessarily one single ramp design. Straight ramps are simple but can become enormous. Zigzag or spiral ramps reduce ramp volume but complicate turning and stability. The consensus is that some ramp system existed. What's debated is its final architecture and how it changed as the pyramid grew. At Hadnub, archaeologists reported an Old Kingdom ramp system with a steep central ramp and side stairways with post holes, interpreted as a way to use ropes and teams to haul heavy stone. It's not the pyramid ramp, proven, but it's a concrete example of ancient Egyptians using sophisticated hauling design. It supports the idea that steep, controlled hauling was possible with clever rigging. One popular idea is that some ramps may have been internal or partially internal, reducing the need for massive external ramps late in construction. This fits the engineering problem. The higher you build, the more expensive a giant external ramp becomes. But the key point is honesty. Internal ramp remains a hypothesis, not a final proof, and it's debated among experts. Even without cranes, leverage can do astonishing work. Incremental lifting, careful positioning, and repeatable routines can move stone precisely. When you see the pyramid as thousands of repeated placements, not one impossible lift, it becomes human again. A secret technique often turns out to be 1,000 boring steps executed perfectly. Pyramid blocks are impressive, but not all joints are microscopic perfection. Builders used mortar and practical tolerances, reserving extreme precision for critical areas. The strategy looks modern. Allocate precision where it matters most, use efficient methods where it doesn't, and keep the overall geometry consistent. The Great Pyramid originally had smooth white casing stones, making it shine. Many were removed over centuries, leaving the rougher core visible. This matters because today's unfinished look feeds myths. People forget they're viewing a monument after thousands of years of stripping and erosion. Human intuition fails at scale. When something is big enough, we assume it must be supernatural. But the real story is harder and more impressive, organizing labor, food, schedules, transport, and quality control for years. The pyramid is not a magic trick, it's project management at civilization scale. Some details remain open questions, especially the exact ramp strategy for the highest stages, and the full day-to-day workflow across decades. But unknown details is not no explanation. We have enough evidence to replace magic with engineering, quarries, tools, transport records, and workforce archaeology. The pyramids aren't proof of magic. They're proof of what humans can do with stone, geometry, logistics, and relentless organization. The real secret is that ancient engineering wasn't primitive, it was optimized for the world they lived in. Comment which part shocked you most: quarrying, transport, ramps, or workforce, and subscribe to World of Mysteries for the next investigation.